Hi, welcome back. In the last video, we looked at an introduction to trigonometry by talking about a new way that we're going to be labeling our triangles for this unit, where we're going to be looking at right triangles. It always has to be a right triangle. We're going to first identify that hypotenuse, and then we're going to say, from an angle's perspective, either in this case A or B, we're going to look and see which side would be the adjacent leg right next to that angle, which one would be the opposite leg across from that angle. Okay, and then we practiced a few times labeling triangles as adjacent, opposite, and hypotenuse, starting always with the hypotenuse and then usually the adjacent next, followed by the opposite. Okay, and we did that a few times. Now we're going to see why it's important that we can identify the hypotenuse, the adjacent, and the opposite sides. Okay, we are going to look at something called trigonometric ratios. And remember, a ratio is just a fancy word for fraction. So yes, we are going to be working with fractions. And this funny word that we see here, SOHCAHTOA, is the word that we're going to want to know to do trigonometry in this class. Okay, SOHCAHTOA is an acronym that tells you how to set up trigonometric ratios of sine, cosine, and tangent. Okay, when you see so, that's going to tell you that the sine of an angle is the ratio of the opposite side to the hypotenuse. Ka is a reminder that the cosine is the ratio of the adjacent side to the hypotenuse. And then TOA is a reminder that the tangent is the ratio of the opposite side and the adjacent side. Oops, I already have an A there. Adjacent side. Okay, so you can see why it's important that you can distinguish the hypotenuse, the opposite, and the adjacent sides so that we can do these ratios. Okay, let's look at an example. Let's say I want to find the sine, cosine, and tangent with respect to angle A. Okay, remember I said the very first thing you're always going to label is your hypotenuse. So if I come over here to this triangle and I label the hypotenuse, okay, so I know my hypotenuse has a value of C. Okay, then I say, okay, what angle am I standing at? For this first one, I'm going to be looking at angle A. So I'm going to be standing right here at A for apple, okay? Which means if I put my pen down and I highlight the side that's not the hypotenuse, B is going to be my adjacent side. And then all the way across from that angle, A is going to be my opposite side, okay? Sine is the ratio of the opposite to the hypotenuse, the ratio of the opposite to the hypotenuse. So in this case, my opposite side has a value of A, and my hypotenuse has a value of C. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. My adjacent side is B. My hypotenuse is C. Okay? Then my last one, tangent, TOA, opposite over adjacent, up over adjacent. My opposite side has a value of A, and my adjacent side has a value of B. So with respect to angle A, the sine of angle A is the ratio A to C. The cosine of angle A is the ratio B to C, and the tangent of angle A is the ratio of A to B. Okay, now let's look at if I move to angle B. Okay, so if I move to angle B, my hypotenuse doesn't move, it's still in the exact same place. But if I put my pen down here, my adjacent side switches, right? This side here that has the value of A is now my new adjacent side. And then across from there, I see my new opposite side. So it depends on which angle you're being asked to find the sine, cosine, and tangent of. The sine of angle B, opposite over hypotenuse, my opposite now is B, but my hypotenuse didn't change. My hypotenuse is still C. Then if I look at B for cosine, adjacent over hypotenuse, my adjacent is A, and my hypotenuse is still C. And then last but not least, the tangent of angle B, the opposite over the adjacent, my opposite is B, and the adjacent is A. Okay, so what you'll see happen is the angle, the sine of angle B is the ratio B over C. The cosine of angle B is the ratio A over C, and the tangent of angle B is B over A. What's kind of interesting is when you look at the figure, what you're going to see happen is your angle A and your angle B, the sine and the cosines, kind of just switch places, if you see that. Okay? So the sine of angle A is the cosine of angle B, and the cosine of angle A is the sine of angle B. And then look what happens on my tangents. On my tangents, they are reciprocals of each other. They're just flipped over versions of each other. Okay? That's always going to be the case no matter what. Okay? In the next video, we are going to see how that applies to triangles with actual values. Okay? So make sure you come back to the next video to see how to apply the trigonometric ratios of sine, cosine, and tangent when you have actual values for your side lengths. All right? Come on back. I'll see you in the next video.